Welcome to another variation of parameters example. So in this example, our job is to find the general solution to x to the fourth times the fourth derivative of y plus 6x cubed times the third derivative of y plus 2x squared times the second derivative minus 4x times the first derivative plus 4y equal to 3x squared plus 5 using variation of parameters to do so. Little hint, I already found the homogeneous general solution for you. We have y1 is x, y2 is 1 over x, y3 is x squared, and y4 is 1 over x squared to form a fundamental set of solutions for the corresponding homogeneous equation. So for this problem, our P0 of x is x to the fourth. Our f of x is that 3x squared plus 5 on the right. If we assume that y is equal to c1 times x plus c2 times 1 over x. Sorry, not c1. If we assume y is equal to u1 times x plus u2 times 1 over x plus u3 times x squared plus u4 times 1 over x squared, we have the u prime, uj prime is equal to -1 to the, in this case, n is equal to 4, since we're looking at a fourth order equation. So -1 to the 4 plus j times f of x was 3x squared plus 5 divided by P0, so divided by x to the fourth, and then times wj over w. So our job is to find those w and wj. So w is the determinant. We do y1, y2, y3, y4 across the top. So y1 was x, y2 is 1 over x, y3 is x squared, and y4 was 1 over x squared. Take the derivatives going down each column. So that first column, we would then have a 1, 0, 0. Derivative of 1 over x is -1 over x squared. Derivative of that is a positive 2 over x cubed. And derivative of that is a -6 over x to the fourth. Taking the derivatives of x squared, we get 2x followed by 2 followed by 0. And then the derivatives of 1 over x squared, we would get a -2 over x cubed followed by a positive 6 over x to the fourth, followed by a -24 over x to the fifth. So W, our Wronskian, is the determinant of this matrix. We can go ahead and do our submatrices. So W1, we eliminate the first column and the last row. We always eliminate the nth row. So eliminating the first column and the last row, we have 1 over x, -1 over x squared, and 2 over, sorry, -1 over x squared and 2 over x cubed as our first column. Then we have x squared 2x, 2. And then we also have 1 over x squared, negative 2 over x cubed, and 6 over x to the 4th. So this is our W1, is the determinant of this matrix. W2, we eliminate the second column and the last row. So we have x, 1 over, we'll eliminate the 1 over x column. So we have x, x squared, and 1 over x squared as the tops. Our first column will be x, 1, 0. Second column will be x squared, 2x, 2. And the last one would be 1 over x squared, negative 2 over x cubed, 6 over x to the 4th. Again, this is just that matrix we used for the Wronskian, eliminating the second column and the last row. We can find W3. This time around, we eliminate the third column in the last row. So we have x, 1, 0 from the first column. We have 1 over x, negative 1 over x squared, and positive 2 over x cubed from that second column. And then from the last column, we have 1 over x squared, negative 2 over x cubed, and 6 over x to the 4th. And then finally, we also need W4. Again, this time we eliminate the fourth column in the last row. So from the first column, we keep x, 1, 0. From the second column, we keep 1 over x, negative 1 over x squared, and 2 over x cubed. And from the third column, we keep x squared, 2x, 2. So we need to find a whole bunch of determinants of 3 by 3 matrices. So in finding the determinant of this first one, for W1, I am just going to do, we will have, if we do our copying of our first two columns, we'll have a 1 over x, negative 1 over x squared, and 2 over x cubed, and then x squared, 2x, and 2. So we'll have a positive 1 over x times 2x times 6 over x squared, x to the 4th. We'll have a positive x squared times negative 2 over x cubed times 2 over x cubed. And we will have a positive 1 over x squared times negative 1 over x squared times 2. And then beyond that, we will subtract off 1 over x squared times 2x times 2 over x cubed. That's our first backwards diagonal. We will subtract off 1 over x times negative 2x over x cubed times 2. It's our second backwards diagonal. And we'll subtract off x squared times negative 1 over x squared times 6 over x to the 4th as our last backwards diagonal. I apologize, I need to update my screen. All right, so here are all my circles for what I'm going to do. This trick only works for determinant for 3 by 3. Technically, it also works. Well, yes, this only works for 3 by 3 determinants. So for this, we wind up getting the first one. We have 1 over x times 2x is just 2 times 6 over x to the 4th would be 12 over x to the 4th. Then we are adding on x squared times negative 2 over x cubed would be negative 2 over x times 2 over x cubed. We would get minus 4 over x to the 4th. Then we have we're adding on 1 over x squared times negative 1 over x squared would be negative 1 over x to the fourth times 2. So we have minus 2 over x to the fourth. Then we are subtracting off 1 over x squared times 2x would be 2 over x times 2 over x cubed. We would get 4 over x to the fourth. Again, we're subtracting this, so minus 4 over x to the fourth. Then we are subtracting off 1 over x times negative 2 over x cubed times 2. So we are subtracting it off a negative 4 over x to the fourth, or in other words, adding on 4 over x to the fourth. And then that very last one, we have a we're subtracting off x squared times negative 1 over x squared times 6 over x to the fourth. So we are subtracting off negative 6 over x to the fourth, or adding 6 over x to the fourth. This winds up with 12 minus 4 is 8, minus 2 is 6. The minus 4 and plus 4 cancel, and then plus 6, we wind up getting 12 over x to the fourth. So we know that W1 is 12 over x to the fourth. Doing the same thing for W2. We have our forwards diagonals, which we will add on. I need to do my copying of the columns. So we'll copy x1, 0, and copy x squared, 2x, 2. We are going to add on our forward diagonals and subtract off the backward diagonal products. And we wind up getting, we have x times 2x times 6 over x to the fourth would wind up giving us 12 over x squared. X squared times negative 2 over x cubed times 0 is just 0. And then we have 1 over x squared times 1 times 2. We're looking at plus 2 over x squared. That first backwards diagonal is again 0, so we are subtracting off 0. Then we are subtracting off x times negative 2 over x cubed times 2. Would be a negative 4 over x squared, but we're subtracting, so that becomes plus 4 over x squared. And then last backwards diagonal, we are subtracting off x squared times 1 times 6 over x to the fourth. So this is subtracting 6 over x squared. The 2 over x squared plus 4 over x squared minus 6 over x squared all cancel each other out, and we just wind up with 12 over x squared. Now we move on to W3. Again, just copying the first column and second column. Once again, we will add on our forwards diagonals. And subtract off the backwards diagonals. And we are looking at that first diagonal, x times negative 1 over x squared would be negative 1 over x, times 6 over x to the fourth would be a negative 6 over x to the fifth. That second diagonal is just 0. The last forward diagonal, we have 1 over x squared times 1 times 2 over x cubed is a plus 2 over x to the fifth. Our first backwards diagonal is just 0, so we're subtracting off 0. Then we are subtracting off x times negative 2 over x cubed times 2 over x cubed. This is subtracting off negative 4 over x to the fifth. In other words, adding 4 over x to the fifth. And then our last backwards diagonal, we have subtracting off 1 over x times 6 over x to the fourth. So we are subtracting 6 over x to the fifth. In this case, the 2 over x to the fifth and 4 over x to the fifth counteract one of those, negative 6 over x to the fifth, and we are just left with 6 over x to the fifth. Our final WJ, finding W4, again, copying those first two columns. We have x1, 0, 1 over x, negative 1 over x squared, and 2 over x cubed being copied. We add our forwards diagonals. And subtract off those backwards diagonals. And we are looking at x times negative 1 over x squared is negative 1 over x times 2. We have a negative 2 over x. 1 over x times 2x times 0, we're just adding on 0. X squared times 1 times 2 over x cubed. We are adding on a 2 over x. Backwards diagonals, that first backwards diagonal is just 0, so we're subtracting off 0. Then we subtract off x times 2x times 2 over x cubed, which will be the same as subtracting 4 over x. Last backwards diagonal, we are subtracting 1 over x times 2. So we are subtracting off 2 over x. Negative 2 over x and 2 over x cancel each other out, and we're just left with negative 4 over x minus 2x, which is negative 6 over x. I apologize, my screen is not updated in the morning. All right. For W3, I had frozen before my last term was written. That was a minus 6 over x to the fifth. And that total sum becomes 6 over x to the fifth. For our W4, our first forwards diagonal was negative 2 over x. Then we had plus 0. Our next forwards diagonal was plus 2 over x. For backwards diagonals, we are subtracting off 0. Next backwards diagonal, we're going to subtract off that 4 over x. And last backwards diagonal, we are subtracting off 2 over x, giving us negative 6 over x. So at this point, we have all of our w's, or wj's. W, we can find by doing negative 1 to the 4 plus 1 times W1 times what is in the very last, what's in the space. The fourth row, first column is 0, so we would multiply by 0. Then we would add on negative 1 to the 4 plus 2, that's n plus j, times W2, times what is in the last space of that second column, which was negative 6 over x to the fourth. Then we add on negative 1 to the 4 plus 3 times W3 times what's the last number in that third column, which was once again 0. And we add on negative 1 to the 4 plus 4 times W4 times the last entry in the fourth column, which was negative 24 over x to the fifth. So our first And part and our third part here, we're just 0. W2 was 12 over x squared. W4 was negative 6 over x. So we are looking at W is negative 1 to the 4 plus 2 is positive 1. W2 was a 12 over x squared times negative 6 over x to the 4th. Negative 1 to the 4 plus 4 is, again, positive 1. W4 was a negative 6 over x. And then we are multiplying by negative 24 over x to the 5th. So we are looking at a negative 72 over x to the 6th plus 144 over x to the 6th. And this is just 72 over x to the 6th. At this point, we have all the information we need. We know that u1 prime was negative 1 to the 4 plus 1, or negative 1 to the 5th, times f of x over p0 of x. F of x was 3x squared plus 5. P0 of x was x to the 4th, so 3x squared plus 5 over x to the 4th. Then we are going to multiply by our W1 was 12 over x to the 4th. Divided by W, which was 72 over x to the 6th. So we have our u1 prime as negative. We have 3x squared plus 5 over x to the 4th times 12 over 72 is just 1 over 6. X to the 6th would move up top, and we'd actually just simplify to x squared over 6. And so we wind up getting negative 3x squared plus 5 divided by 6x squared for our u1 prime. For u2 prime, we are looking at negative 1 to the 4 plus 2, or negative 1 to the 6th. Again, times 3x squared plus 5 over x to the 4th times our W2 was 12 over x squared. So we have times 12 over x squared over 72 over x to the 6th. This just becomes a positive 3x squared plus 5 over x to the 4th times, we would wind up with an x to the 4th up top divided by 6. Or in other words, 3x squared plus 5 all over 6 for the simplified version of u2 prime. For u3 prime, we would have negative 1 to the 4 plus 3, or negative 1 to the 7th, times 3x squared plus 5 over x to the 4th. And we would multiply by W3, which was 6 over x to the 5th. And divide by our W, which was 72 over x to the 6th. This becomes negative 3x squared plus 5 over x to the 4th times 6 over 72 would be 1 over 12, and we'd be left with x over top divided by 12. And we get negative 3x squared plus 5 divided by 12x cubed. For our u4 prime, we are looking at -1 to the 4 plus 4, or -1 to the 8th, times 3x squared plus 5 over x to the 4th, times w4 was -6 over x. So we will multiply by -6 over x over 72 over x to the 6th. -1 to 8, the 8th is positive. Then we have 3x squared plus 5 over x to the 4th times a negative x to the 5th over 12, leaving us with a negative 3x cubed plus 5x, negative out front, all over 12. So at this point, we can go ahead and integrate to find the u sub j. So we had u1 prime was -3x squared plus 5 over 6x squared. The negative out front, and then 3x squared plus 5 over 6x squared. So we are just looking at a -1/2 minus 5/6 x to the -2. u1 is therefore the integral of -1/2 minus 5/6 x to the -2 dx. And that will give us -1/2 x plus 5/6 times x to the -1. And then, of course, plus c1. So this is our u1. u2 prime. We had 3x squared plus 5 all over 6. So we are looking at 1/2 x squared plus 5/6 is our u2 prime. So we have that u2 is the integral of 1/2 x squared plus 5/6 dx. And therefore we get u2 is 1/6 x cubed plus 5/6 x plus c2. So this is our u2. u3 prime is equal to -3x squared plus 5 over 12x cubed. Otherwise known as a -1/4 x to the -1 minus 5/12 x to the -3. Taking this integral, we get that u3 is equal to the integral of -1/4 x to the -1 minus 5/12 x to the -3 dx. And this is, of course, -1/4 times the natural log of x plus 5 over 24 x to the -2 plus c3. For u4 prime, u4 prime was equal to a -3x cubed plus 5x over 12. the negative out front, and then 3x cubed plus 5x, all divided by 12. Otherwise known as a negative 1/4 x cubed minus 5/12 x. Taking this integral, we get that u4 is equal to the integral of negative 1/4 x cubed minus 5/12 x dx. And we get that this is equal to negative 1/16 x to the 4th minus 5/24 x squared plus c4. So at this point, we have all of our u's. So we can put this together to form y. So now we will find y, which was equal to u1 times x plus u2 times 1/x plus u3 times x squared plus u4 times 1/x squared. So we need to plug all of these in. Our u1 was negative 1/2 x plus 5/6 x to the negative 1 plus c1. So we have y is equal to x times negative 1/2 x plus 5/6 x to the negative 1 plus c1. Then we have plus 1/x times our u2, I apologize for all the scrolling, was 1/6 x cubed plus 5/6 x plus c2. So we'll do 1/x times 1/6 x cubed plus 5/6 x plus c2. That we will add x squared times our u3. u3 was a negative 1/4 natural log x plus 5/24 x to the negative 2 plus c3. So we have a negative 1/4 ln of x plus 5/24 x to the negative 2 plus c3. And then finally, our 1/x squared is multiplying u4, which we found to be negative 1/16 x to the 4th minus 5/24 x squared plus c4. So that 1/x squared is multiplying negative 1/16 x to the 4th minus 5/24 x squared plus c4. Multiplying this out, we are looking at y is equal to, we have a negative 1/2 x squared plus 5/6 plus c1x. Then we have plus 1/6 x squared plus 5/6 plus c2 times 1/x. Then we have minus 1/4 x squared times the natural log of x plus 5/24 x to the negative 2. Sorry, plus 5/24 plus c3 times x squared. And then we would have minus 1/16 x squared minus 5/24 plus c4 times 1 over x squared. I'm just verifying my U3. So our U3 prime okay, I'm just verifying we should have that natural log. All right, so at this point, we have sort of all of the components of our solution. The natural log was a little surprising to me. I was expecting, was not necessarily expecting that, but let's see what happens. Since we did have our repeated since we did have x and x squared were homogeneous solutions, that does complicate things a little. So we have a plus 5/6 and a plus 5/6, and then we have a plus 5/24 and minus 5/24 for the constant components. So those cancel each other out, and we just have 10/6. For our x squared component, we have a negative 1/2, a plus 1/6, which would be negative 1/3 there, and then minus 1/16. We would be looking at a negative 16/48 minus 3/48 for a negative 19/48 x squared plus 5/6 plus 5/6 is 10/6 or 5/3. And then we have minus 1/4 x squared times the natural log of x. And then followed by our homogeneous plus c1x plus c2 times 1 over x plus c3 times x squared plus c4 times 1 over x squared. So again, assuming I did not make any arithmetic errors in the process, which is always possible when I'm doing math out loud. This would be our general solution. So this is variation of parameters for a fourth order differential equation.